There's a pipe sticking out of the side of your house. White PVC, about the diameter of a soda can, 30 inches off the ground, maybe near your air conditioning unit, maybe a little further down the wall. You've walked past it 1,000 times. It drips, steadily when the AC is running, into a patch of darker dirt that never quite dries out in summer. That pipe is the drain line of a $4,000 dehumidifier you didn't know you owned. 10 to 25 gallons of distilled-grade water a day. Every day the AC runs. Pulled out of your indoor air, sent into the ground. The EPA pulled samples. What they found is the difference between irrigation water and drinking water, and it's the reason you can't just stick a glass under that drain. We get there. First, the pipe. Cape Town, February 2018. Population 4 million. The city's countdown clock read 60 days until day 0, the day the taps go dry. By March, the rationing was 13.2 gallons per person per day, for everything. Drinking, cooking, washing, the toilet. 13.2 gallons. That's 2 flushes of an old toilet, or 1 shower under 3 minutes, or 4 full kettles. You pick. Most people don't think about water until the tap stutters. The Cape Town residents who came out best had something most homeowners never carry, a map of which appliances in their houses secretly produced water, and which secretly burned it. A house has a thermal water electrical bookkeeping. Money goes in, energy goes in, water goes in, things come out. If you don't know what comes out, you don't know your house. Walk to the side of your house tonight. Find the drain stub. White PVC. Sticking out of the wall maybe 2 feet, maybe 4. There's a darker patch of dirt under it. That patch is the receipt. Most homeowners can't tell you what's in that water. The honest answer, it's nearly distilled. Below 10 parts per million dissolved solids on most days. Tap water runs 200 to 400. So if you've been wondering why your tap has that mineral taste, that's the gap. Tap carries minerals. Condensate carries almost nothing. You can verify this for $15. A TDS meter, total dissolved solids meter, from Amazon. Pen-shaped, looks like a thermometer. Dunk the tip. Read the screen. 2 readings, 1 from your tap, 1 from a glass of fresh condensate off the drain pipe. The numbers tell you what your AC has been doing all summer that you didn't notice. Here's the math that should bother you. A 3-ton residential AC unit, typical for a 1,500 square foot house in a humid summer, pulls 20 to 25 gallons of water out of the indoor air on a hot day. Some days more, some days less. We'll get to the curve in a minute. For now, hold the number. In Cape Town, that 25 gallons would have nearly doubled the daily allowance for any household with central AC. The supply existed. The visibility didn't. The pipe you walk past every day is producing more water, on a hot Tuesday, than the entire Cape Town rationing budget for 2 adults. That's the pattern. Infrastructure that produces the resource you need is invisible because it was never sold to you as that. It was sold to you as cooling. The water is a side effect, the same way a refrigerator's job is technically heat pumping, and the cold inside is the side effect. We're going to look at how that side effect happens. The physics is light. Once you've seen it, you can never walk past that pipe again without doing the math. Then we look at what the EPA found when they tested the water in those drain lines. Because it matters which side of the irrigation versus drinking line the contents are on. But first, what is your AC actually doing when it's running? Vapor compression cycle. 4 parts: compressor, condenser, expansion valve, evaporator. Refrigerant cycles between them. The compressor squeezes the gas, Pressure goes up, temperature goes up. The outside condenser dumps that heat to the outdoor air. The expansion valve drops the pressure. The indoor evaporator absorbs heat from your indoor air. That's the part that matters here. The evaporator coil is cold. 40 degrees Fahrenheit, sometimes lower. Your indoor air at 75 degrees, 60% humidity, hits that coil and drops below its dew point. The water vapor in that air has nowhere to stay airborne. It condenses. On the coil, on the fins, on the drain pan beneath. Then it runs down into the condensate line, out through that white PVC stub. That's it. The physics fits in one paragraph. Now the volume. A 1-ton AC unit, 12,000 BTUs per hour of cooling capacity, running in 80-degree air at 60% relative humidity, pulls about 3 pints of water per hour out of that air. 3 pints per hour. 8 hours of typical daily cooling. 24 pints. 3 gallons per ton per day. A 3-ton unit, typical for a 1,500 square foot house. 3 times that. 9 gallons on a moderate day. 20 to 25 gallons on a hot, humid day, when the AC runs longer and the air is wetter. That number is the difference between a passive dew catcher and an active dehumidifier. A sheet of plastic over a frame yields a few cups overnight, when the sky and the air cooperate, measured in cups in most climates. Occasionally a gallon when the weather lines up. The vapor compression machine running in your wall manufactures the cold. The coil is 40 degrees, regardless of what the sky is doing. As long as the AC runs, water condenses. Continuously. From late morning until late evening on a typical summer day. That's the engineering twist most homeowners miss. The appliance you bought to cool your house is also the most reliable water condensing machine you'll ever own, running 9 to 12 hours a day during cooling season. On one project, I spent 2 summers reading condensate line failure reports for a commercial HVAC portfolio. Compressors rarely failed under 5 years. Drain lines clogged with biofilm or cracked at the trap once or twice a season per unit. Back to your house. 2 pieces of equipment to track what your wall is producing before any install. TDS meter from Amazon, $15. Pen-shaped, runs on a coin battery. We covered the use already. Read your tap, read your condensate, see the gap. 5-gallon HDPE jerry can from Walmart, $14. Stackable, BPA-free. Square sides for storing against a wall. Skip the transparent ones. Sunlight through clear plastic encourages biofilm growth. Pick the opaque blue or beige version. Set the can under your drain pipe for a single hot afternoon. Check it before bed. The number on the side of the can, that's your house's daily summer yield. That number is the math that should change how you think about your wall. Walk to your thermostat. What does it say? If it says cooling, somewhere in your house, water is dripping right now. Here's the part where the optimism stops. In October 2018, 3 EPA scientists, Daphne King, Michael Jahne, and Stacy Pfaller, from the agency's Office of Research and Development, presented findings at the 8th Conference on Biofilms in Washington, D.C. The paper title is Dry, quote, _0, _. The data is anything but dry. They tested 4 air handling units in 2 North Carolina buildings. Bi-weekly samples, May through October 2017. 6 months of summer cooling. They measured what was coming out of those drain lines and what was growing on the surfaces inside the drain pans and the condensate piping. The first number that should give you pause. Average heterotrophic plate counts of 6,050 colony-forming units per milliliter. The EPA's recommendation for potable water is under 500. So the bulk condensate they sampled was running about 12 times above the threshold. 12 times. The second finding is more specific. Mycobacterium intracellulare and Mycobacterium chimera, both opportunistic pathogens, were detected in 7.5% of the condensate samples. 3 out of 40. These are the slow-growing mycobacteria associated with pulmonary infection, particularly in people with compromised immune systems. The third finding ends the casual conversation. Legionella pneumophila serogroup 1, the agent responsible for Legionnaire's disease, was detected in one of the condensate samples and one of the biofilm samples. Legionnaire's is a pneumonia. The serogroup 1 strain accounts for the majority of clinical cases. Same drain pan, same line, same water that was 10 seconds earlier, near-distilled, coming off the coil. The chemistry on the cold side of the coil is one story. The biology a few inches downstream of it is another. Coming off the evaporator, the water is essentially clean. By the time it is pooled in the drain pan, sitting in stagnant, warm, dark conditions, mixed with dust, skin cells, and outdoor pollen pulled in through the return air, it has spent enough hours in those conditions to grow a culture community on the metal and on the sidewalls of the pipe. That's why the EPA's actual conclusion in the paper matters, and why misquoting it is dangerous. The paper concludes something narrower than safe to drink. With appropriate disinfection, condensate can be reused for non-potable purposes: irrigation of landscape plants, cooling tower makeup water, toilet flushing. Drinking-grade reuse requires further treatment beyond simple disinfection. So here's how to think about the water from that pipe by use category. For your garden, your fruit trees, your lawn, collected condensate works as is, or with a light chlorine treatment if it's going to sit more than a day. Standard household bleach. 8.25% sodium hypochlorite, which is the Walmart $3 gallon. 8 drops per gallon of condensate. Stir. Wait 30 minutes. Use. For toilet flushing, washing hands at the outdoor spigot, washing tools, rinsing concrete. Same chlorine spec. 8 drops per gallon. 30-minute wait. The chlorine residual handles the bulk of the heterotrophic load and the Legionella concern for that use category. For drinking, different ladder entirely. You need reverse osmosis, followed by ultraviolet sterilization, or distillation again, running the already condensed water through a second condensation step, which is what countertop distillers do. A SteriPen UV pen from Amazon, $50, is a backup tool for individual quart volumes if the rest of your treatment chain fails. By itself, over drain pan water, the SteriPen is insufficient. Treat it as the last filter, never the only one. Here's the relief, because there is one. Your AC has done 99% of the work for you. Pulling water out of indoor air at industrial scale, year after year, on a single-phase residential electrical circuit. The biology party in the drain pan is the last 1%, and the last 1% is solved with $3 of bleach and 30 minutes of patience for everything below the drinking line. The EPA wrote this paper for a different reason than scaring homeowners. They wrote it to demonstrate that with proper handling, an enormous water resource is sitting in commercial buildings and homes everywhere and being thrown into dirt patches. King, Jahne, and Pfaller mapped the pathogens, named them, and stratified the safe uses. The tools to handle the load are at the corner store. The pathogens place condensate firmly in the irrigation water category and set a treatment ladder for any use above that line. The drain pan is where the bacterial load accumulates, and the chlorine step, or the RO/UV step, is what brings it back into the safe envelope for the use you have in mind. 3 hours, $40, one trip to one store. Here's the bill of materials. Read it once, then drive. 3/4-inch PVC tee, plus a hose bib spigot. Home Depot. $7 to $9 total depending on stock and brand. The tee splices into your existing condensate line. The bib gives you an on-off valve and a connection point. 5-gallon HDPE jerry can, Walmart, $14. Same one we covered earlier, opaque, BPA-free, stackable. 1/2-inch backflow preventer, Home Depot, $4. Goes between the bib and the jerry can. Keeps the can's contents from siphoning back up the line into your drain pan, in the rare case of a vacuum event. Cheap insurance. Inline 5-micron sediment filter, Lowe's, $12. Sits in the line, catches the visible debris before it reaches the can. Biofilm flakes, mineral grit from the coil, the occasional dead insect. Total, $37 to $43. One trip, one store if you pick Home Depot, and grab the filter on the same run. Procedure. Cut the existing condensate PVC outdoors at a comfortable working height. Insert the tee. Glue with PVC cement. 15-minute set. Thread the bib into the tee branch. And tight, plus a quarter turn with a wrench. Attach the backflow preventer downstream of the bib. Run a short flexible hose into the top of the jerry can. Leave room for venting. That's the install. 3 hours total. Most of that is glue cure and dry time. Active work, under 30 minutes. One thing you don't do. Substitute a galvanized metal pail because it was sitting in your garage. A sea condensate is near-distilled. Distilled water is mineral-hungry. It pulls cations out of whatever it touches. Galvanized steel is zinc-coated. The water leaches zinc into solution. You took clean condensate and turned it into low-grade zinc water before you even disinfected it. Use HDPE. Use polypropylene. Use food-grade stainless. Galvanized goes in the recycling. Now the climate context, which decides whether this install pays. Phoenix, Arizona, summer 2023. The heat dome. Maricopa County logged 31 consecutive days over 110 degrees Fahrenheit. 645 heat-related deaths that summer. A C ran 24 hours a day for the homes that had functioning units. Phoenix in summer runs at 15 to 25% relative humidity, low for condensate yields. A 3-ton residential unit there logs 4 to 8 gallons per day during the dome, a fifth of what a Houston unit would produce on the same calendar day. Modest by humid climate standards. But 4 gallons a day for 31 days is 124 gallons. Free, distilled grade. Coming out of the wall of a desert house during the worst recorded heat event in the city's history. The kind of week when the city was sending out cooling center buses and water truck deliveries to vulnerable neighborhoods. 124 gallons sitting in a drain pan and going to dirt. The pattern repeats. Cape Town, Phoenix, Houston in a hurricane summer. Anywhere the AC runs longer than the rain falls, the condensate pipe is producing what the city is rationing. And the $40 tap install is what turns that flow from a stain in the dirt into a 5-gallon container you can lift and carry. A few install discipline points before the next block. The can sits on a level surface because 40 pounds of water tips. A second can stays on hand because filling one in 8 hours during a heat wave is normal, and an unattended overflow flushes back into the drain pan. Tape a small piece of paper to the can with the install date. Useful for tracking yield over the season and for knowing when the sediment filter needs swapping. The honest answer about whether this works for you depends on where you live and what season it is. Humid climates pay best. Houston, New Orleans, Atlanta, the entire Gulf Coast, the Mid-Atlantic, the Carolinas, summer Memphis, summer Chicago. 15 to 25 gallons per day from a 3-ton residential unit on a typical July afternoon. Houston ambient runs 85 to 95 degrees, 65 to 80% relative humidity. Your AC works hardest in those conditions. The condensate volume mirrors the work. Dry climates pay smaller. Phoenix, Albuquerque, Las Vegas, Southern California inland, 4 to 8 gallons per day from the same 3-ton unit during a hot, dry spell. The lower humidity means less water in the air to start with. The yields are real and worth collecting. Smaller, but the 4 to 8 gallon range compounds across a 30-day heat event. Winter everywhere, AC off, condensate dry. The system you're installing is a summer water source. It runs from roughly May through September in most of the country, with edge weeks in April and October. October to April, the pipe is dead. A $10 portable hygrometer from Amazon, battery-powered, sits on a counter. Tells you what your indoor RH actually is. Run it for a week. The number you see is the input to the equation. High RH, summer days, you're collecting 20 gallons. Low RH, or off-season, you're collecting nothing. Plan accordingly. Now the harder edge. Hurricane Maria, Puerto Rico, September 2017. The grid took 11 months to come back fully. Some neighborhoods went a year. Every AC dark for that duration. Every drain pan dry by the second day. Every refrigerator a petri dish. Condensate was 0 from minute 1 of grid failure, and 0 through the entire 11-month restoration window. That's the limit. Condensate is a tool of the summer grid-up case. For collapse resilience or off-season needs, you need a different water stack, rain catchment, well water, stored reserves, all maintained independent of the AC. Use the tap install for the season and the scenario it covers. Layer other sources beneath it for everything else. One step. Tonight. Walk outside after dinner. Find the white PVC stub on the side of your house, the one that drips when the AC runs. There's almost certainly a darker patch of dirt under it. That patch is the receipt for every cooling day this summer. Place a clean, opaque 5-gallon container directly beneath the drip line. Any opaque food-grade vessel, the $14 Walmart HDPE jerry can we covered, or whatever you have on hand. No funnel, no fittings, just a container catching what falls. Then go to bed. In the morning, before coffee, walk back outside. Lift the container. The weight in your hands is what your AC has been giving away into the dirt every cooling day this summer, and every cooling day last summer, and every cooling day before that. The same water your city would be rationing if the dam went dry next week. You'll see what your AC has been giving away, and what your neighborhood will be looking for the day the city can't deliver. If the container has weight, the install is a Saturday project. $40 at the corner store. 3 hours, most of it glue cure. The hardware list and the disinfection ladder are both above. Both are short on purpose. Set the bucket out tonight. Check it before breakfast. The number tells you how big a tap to install.